Latin square designs. Latin square designs are a statistical method that allow you to control or eliminate two sources of nuisance variability. Both of the rows and the columns can be used as blocking factors. The Latin square design gets its name from the fact that we can write it as a square with Latin letters to correspond to the treatments. The treatment factor levels are the Latin letters in the Latin square design. The number of rows and columns has to correspond to the number of treatment levels. So, if we have 4 treatments, then we would need to have 4 rows and 4 columns in order to create a Latin square. This gives us a design where we have each of the treatments in each row and each column. A Latin square design is a method of placing treatments so that they appear in a balanced fashion within a square block or field. Treatments appear once in each column and row. Replicates are also included in this design. Treatments are assigned at random within rows and columns, with each treatment once per row and once per column. There are equal numbers of rows and columns and treatments. Here's an illustration of a Latin square design. As you can see, there are 4 columns and 4 rows, making it a 4x4 square. You can have any size square that you want for any number of treatments, but all of the rows and columns and treatments must be equal. Here are the advantages of a Latin square design. They can handle the case when we have several nuisance factors and we either cannot combine them into a single factor or we wish to keep them separate. They also allow experiments with a relatively small number of runs. The disadvantages of Latin square designs are as follows. The number of levels of each blocking variable must equal the number of levels of the treatment factor. Also, the Latin square model assumes that there are no interactions between the blocking variables or between the treatment variable and the blocking variable. Here is an engineering application example of a solar energy plant. We have 5 different operators and 5 different photovoltaic modules. The 2 nuisance factors for this example are the operators and the PV modules. Here's the Latin square design for this example. I ranked the PV modules and operators from 5 to 1, with 5 being the best and 1 being the worst, and then I multiplied the PV rank by the operator rank. This Latin square design for the solar energy plant easily demonstrates that the operator 3 and PV module 2 combination creates the best solar energy plant based on the skill and experience of the operator and the efficiency levels and costs of the PV module.